Students, we will discuss about how to apply position tolerance to your component. Shown here is a plate containing 4 holes. Size of the holes is 16 H10. These 4 holes are to be located by a certain distance of 50 by 120. As the hole cannot be machined to an exact size, we are assigning a tolerance of H10 for this example. If you look at the tolerance value from the data book, you will find that the tolerance is plus 00 plus 0.7, which means that all the hole has to be finished between 16 and 16.07. Here we have to identify the MMC size of the hole. MMC size refers to the maximum material condition for which size of the hole the plate will contain maximum material. When the hole is at its lowest value, the plate will contain maximum material. So the MMC size of the hole is 16 mm, the lowest size. The LMC size of the hole is 16.07 mm. We want to locate the hole within a center to center distance of 50 by 120. The hole cannot be located by exactly 50 by 120 mm. We have to allow for some error by assigning a tolerance, position tolerance. So position tolerance is assigned by introducing a feature control frame near to the size of the hole. Then we have to introduce the position tolerance. For this example, the position tolerance is 0.8 mm applicable at its MMC size. So the MMC size of the hole is 16 mm. So when the hole is 16 mm, the applicable value of tolerance is 0.08. So since it is not possible to locate the hole exactly by 50 by 120 mm, we are assigning a tolerance, position tolerance using a feature control frame. How to infer the meaning of this 0.08 mm? This 0.08 mm refers to the value of diameter of the tolerance zone, which I am showing here. So we are defining a cylindrical tolerance zone of diameter 0.08 mm applicable at its MMC size of 16 mm. This 4 cylindrical tolerance zone has to be first located. Then once it is located, within the tolerance zone, the whole axis can lie anywhere. The whole axis of this hole can lie within this tolerance zone. That is what is shown in this figure. See here, once the tolerance zone is defined, the red color one shows the tolerance zones. Once the 4 tolerance zones are defined for each of the hole, then the axis of the hole can lie within the tolerance zone. It can be tilted, it can be shifted, but as long as the axes are within their respective tolerance zone, the hole can be accepted as far as location is concerned. So this is the meaning of position tolerance applicable to the feature, a hole feature. In order to apply the position tolerance, first you have to locate the tolerance zone. Cylindrical tolerance zone we have to locate with respect to 3 datum surfaces. Now this tolerance zone, cylindrical tolerance zone, has to be made perpendicular to the one of these 2 surfaces, either the top or bottom surface. So the cylindrical tolerance zone has to be made perpendicular to either the top surface or the plate or bottom surface of the plate. Similarly, the cylindrical tolerance zone has to be located from either the 2 edges, either these right edges or the top edges. So we have to locate the 4 cylindrical tolerance zone with respect to the left edge as well as the top edge. So we have to define 3 datum surfaces for defining the position of the tolerance zone. That is what is shown here. A, B, C are the 3 datum surfaces. So the tolerance zone has to be made perpendicular to the bottom surface of the plate, so that is primary datum A. Similarly, the tolerance zone for the 4 holes has to be located from the datum C and datum B. Okay, this side surface is datum B, this top surface is datum C. So from the top surface, the tolerance zone for the first hole is to be located at a distance of 30 mm. Then the tolerance zone for the second hole is to be located at a distance of 50 plus 30, 80 mm. Similarly, from the datum B, the tolerance zone for this hole has to be located at a distance of 30 mm. The tolerance zone for this hole is to be located at a distance of 120 plus 30, 150 mm. So these dimensions are used to locate the tolerance zone. So any dimension which are meant for locating the tolerance zone are put inside the boxes. So the box dimensions are basic. So these box dimensions are used to locate the tolerance zone within which the axis of the hole can lie anywhere. What will happen if the hole size is deviating from the MMC size of 16 mm? The hole size can vary between 16 and 16.07. As the modifier symbol is present in this feature control frame, the value of 0.08 is applicable only for a MMC size of 16 mm. What will happen if the hole size is deviating from 16 mm? So as per the drawing, 0.08 is the position tolerance diameter when the hole is at its MMC size of 16 mm. If the hole is 16.01, it is deviating from the MMC by 0.01 mm. So 16.01 is the actual size. It is deviating from the MMC size of 16 by 0.01 mm. So this 0.01 has to be added with 0.08, that is equal to 0.09. If the hole size is 16.02, it is deviating from the MMC size by 0.02. So 0.8 plus 0.2, 0.2 is the applicable value of position tolerance when the hole is having a size of 16.02. Similarly, other values are shown. When the hole is at its maximum value of 16.07, this is the LMC size of the hole. The applicable value of tolerance is 0.08 plus the deviation is 0.07. The deviation from the MMC size is 0.07, but both are getting added. So the applicable value of tolerance is 0.15. Suppose if the plate is toleranced with L, so here I am showing a different example where the plate having a 4 holes and the position tolerance is applicable. The position tolerance of 0.08 is applicable at LMC condition. So LMC condition stands for least material condition. When the hole is at its biggest size, the component will have very least material. So the LMC size of the hole is 16.07. So a tolerance value of 0.08 is applicable at LMC size of 16.07. What will happen when it is deviating from the LMC size? That is what is shown in this table. As per the drawing, applicable value of tolerance is 0.8 at LMC size of 16.07. When it is deviating from the LMC size, accordingly it is getting increased. So when the hole is 16.06, it is deviating from the LMC by 0.1 mm. That 0.1 is added, so total is 0.9. When the hole is at its MMC size of 16 mm, it is deviating from the LMC by 0.7 mm. So the 0.7 is added with 0.8, so total value of tolerance is 0.15 mm.